Okay, so now I want to get to this module, thermodynamics, heat and temperature, and all of this cool hot stuff. Sorry, I had to do a sad joke there. But in this first video, I want to go through and cover some of the basics, make sure we're okay on the same vocabulary, we're talking about the same thing, and then we'll get into some of the applications. The applications are really where things get interesting. So you've been using Fahrenheit and Celsius, at least Fahrenheit probably for your entire life. So I wanted to first talk about temperature. And what is temperature? So temperature tells you how warm or cold something is. It doesn't tell you how it feels. That's going to be something very different. But it tells you how if you take a thermometer to it, it'll tell you how warm or cold. So, for example, I know my best friend's mom um, can get overprotective of her grandkids, and she'll feel the grandkid and be like, "Oh, the kid's warm," but the body still is 97.8 degrees, so it doesn't have a fever, but it feels warm, but the temperature is not. So it's all relative. If you have cold hands, something that is normal temperature for a body temperature is going to feel warm. So temperature is literally the measurement of how warm or how cold something is, not how it feels. So that we want to make sure we're doing that. There are three types of kind of units that we use to measure temperature: Fahrenheit, so degrees F, Celsius, degrees Celsius, and Kelvin, which most of you probably have not used. I used it a lot working my astrophysics masters. Kelvin is at absolute scale. We'll talk about that here in a second. Physicists, astronomers love to use Kelvin. So conversions, Celsius is equal to 9/5 times Fahrenheit minus 32. And then if you want to go the other way, this is 5/9 Celsius plus 32. Couple things I think every person should know is when water freezes. I think you should know these temperatures: 32 degrees Fahrenheit and at 0 degrees Celsius. Yes, water can freeze above 32 degrees. It actually can freeze below. Salt water is different than regular water, so depending on what's in the water will be what temperature it can actually go through and freeze. We'll get into that more as well. Water boils. I think everyone should know this as well. It's at 212 degrees Fahrenheit or at 100 degrees Celsius. So those are, most of you are going to cook and boil water, so it boils at 212 degrees Fahrenheit and again at 100 Celsius. So let's go back to this temperature thing. And temperature is not a measure of how it feels. I want to talk about thermal energy. Thermal energy is not temperature. Okay, and I'll give you an example to justify my answer here in a second. This is the amount of kinetic energy the object has. So, like the atoms. So basically, how active are the atoms? If they're not very active, like ice, it's going to have low thermal energy. If it's very active, like boiling water, greater, going through it's greater. So let's kind of go through and look at, if I have some water here at 80 degrees Celsius and I have twice as much water at 80 degrees Celsius, they have the same temperature. But remember, kinetic energy is 1/2 mv squared. So the more mass I have, the more kinetic energy I have. So this has a greater thermal energy. Okay? It has more heat, so to speak, to be able to transfer. So I just want to kind of clarify that. And then I wanted to look at heat, another term that we'll be using a lot. Heat is not temperature either. When you heat something, you transfer energy. So the amount of thermal energy transferred. So remember, when you heat something, you're taking heat from one source and transferring it to another source. When you heat water, you're taking the propane from the heat from your fire of your stove, if you have a gas stove, and you're transferring that to the water, causing the water to warm. So transfer. So these are going to be the three key words here, and making sure we don't use them interchangeably or incorrectly. Now, thermal energy, so heat is, some books like to write this, thermal energy in motion. We all have thermal energy, but it's that thermal energy that's transferring from one object to another. Thermal energy always goes, heat always flows from hot to cold. Okay? So when your parents say you're not heating the outside, when it's cold outside, you leave the door open, or your refrigerator, and with your refrigerator, the hot air actually goes into your refrigerator, so it goes hot to cold. You're not going to cool off your living. The cold air is not coming out. It's the hot air going in. So things are going to go from hot to cold. So I want to talk about this Kelvin here for a second. You may have heard the term absolute zero. Okay, so this is in Kelvin. And 0 Kelvin has never been reached. We've been trying, we never reach it. This is the lowest temperature possible. And this is at the point where the electron will stop going around the atom. It'll just stop spinning. So if you think about it, if you have protons in the nucleus and an electron going around, if it stops moving, it's going to fall in and it's going to crash and have crazy things happening. So at absolute zero, that's where things just stop. We've never gotten to that point. We've tried. We're at half a Kelvin, 1 Kelvin, which is like minus 400 and some odd degrees Celsius or Fahrenheit. Super, super cold. But that's where things just slow down. Think about it. The colder things get, the slower the atoms get. Remember the thermal energy, that slower kinetic energy? The colder things get, the slower they go. And even people. Now, I love the cold. I like to be active in the cold. The heat of Savannah is sometimes overbearing and causes you not to want to move. That's more the humidity than anything else, than the temperature. So what we're going to do next is I want to talk about this. How do we measure this heat? How do we measure how much heat we have to transfer? And so if you remember back when we were talking about energy, I mentioned calories. And so we want to go back and kind of talk about, we've already talked about energy transfer. So in the next video is going to be more a review of the things that we've already talked about, but I want to make sure we review again and we're all on the same page.